अच्छा चलो ये स्टार्ट कर लेते हैं, कहाँ पे थे? आई थिंक वी डिड दिस वन। ये भी शायद कर लेते हैं, ये वाला कर लेते हैं। अच्छा लेट्स स्टार्ट विद दिस वन, जो सामने क्वेश्चन। अच्छा, chlorate 5 ions are powerful oxidizing agents. The reduction of chlorate 5 ions with SO2. तो क्या है? ClO3 with ClO3 with SO2. तो it forms what? Forms क्या कर रहा है? ClO2 and sulfate ions, which is SO4 minus 2. As the only that's it. ठीक है, that's your equation. अच्छा, ये equation जो है ना, that's probably it can be balanced the normal way, but just to ensure, when you have a redox reaction, the number of electrons lost and gained, they have to be equal. तो ये chlorate, sorry, -1 है। अच्छा, तो इक्वेशन में क्लियरली सब कुछ लिखा हुआ है, ठीक है, एवरीथिंग इज रिटन। टेल मी व्हाट इज द ऑक्सीडेशन स्टेट ऑफ Cl ओवर हियर? Okay. Well, what's the oxidation state?
+5.
अच्छा ठीक है, दिस इज +5। तो अच्छा +5 एंड यहाँ पे इट्स आई थिंक +4, राइट? तो इसका मतलब इट्स व्हाट इट्स गेनिंग, इट गेन्स 1 इलेक्ट्रॉन, राइट? अच्छा, सल्फर क्या है? सल्फर इज आई थिंक SO2 था +4 एंड ऑन द अदर साइड इट्स +6, so that means it's what loses 2 electron. So bus electrons gain and loss, they have to be made equal. So when you make them equal, it's going to be इसको you have to Cl has to be multiplied by 2, so it's going to be 2 Cls, and there should be just 1 sulfur. ठीक है, so the electrons gain and loss would be equal. और बस balance हो गया, ठीक है, that's it. So I think oxidants, we count the oxidants, that's 6 plus 2, that's 8. 4 plus 4, that's 8 as well. तो बस ठीक है, it's already balanced. अच्छा, फिर वो कह रहे पार्ट B1, ClO2 disproportionates with hydroxide ions to form a mixture of this and this. Using the reaction as example, what is meant by disproportionation? So that just means that the same element, वो भी बता दो कि it's +4 over here, और ClO2 में it's क्या होगा? ClO2 में it's going to be +3, और ClO3 में it's going to be +5. तो it's going to go from +4 to +5, and it's going to go from +4 to +3. So same element, इसमें बता भी दो, same element gets which is Cl, gets oxidized. तो उसके अंदर states बता दो कि it goes from +4 to +5, and reduced. यानी it goes from +4 to, it goes from +4 to +3 at the same time. अच्छा, reduce the ionic equation for the reaction in half equations. अच्छा, इसकी ना you have to write the reverse, ठीक है? Remember, overall is already given, ठीक है? You're given the overall. तो वो reverse में, ठीक है, is asking for कि वो find out करो what's the reduction and what's the oxidation equation. So I'm going to start with the reduction equation. So what is reduction? It's ClO2, and it becomes ClO2 -1. So it is ClO2 and it's turning into ClO2 -1. +4 to +3. So that means it gained exactly 1 electron. ठीक है, it gained exactly 1 electron. और फिर इसी तरह the oxidation equation. The oxidation equation is that it again starts at ClO2. And it becomes ClO3 minus 1. So ClO2 becomes ClO3 minus 1, +4 to +5, so it lost 1 electron. Except ये वाली equation, the reduction equation is already balanced, right? Remember, I told you that reduction plus oxidation is the final equation. So ये जो oxidation वाली equation है, that's not balanced. It's so that means these two OH ions and the water molecules, because you don't need them over here. This equation is already atom-wise, it's already balanced. You don't need anything else over here. लेकिन इस वाले में the oxygen is not balanced. So that means जब ये दो add हुए थे ना, you got this equation. So that means the OH ions, ठीक है, the two OH ions and your water molecules, which is one water molecule. They are actually, I mean, this water molecule, this OH ion must be coming from this other equation. ठीक है, ये दोनों, these two equations got added up, and then you got this overall equation. ठीक है, तो हमने वो electrons वाली कहानी तो खत्म कर ली थी कि I knew ClO2 turning into ClO2 minus 1, so that's 1 electron gained. ClO2 turning into ClO3 minus 1 plus 5, so that means 1 electron lost. बाकी जो OH ions and water, that must be part of the second equation. If you add them, then this equation gets balanced as well, क्योंकि now you got 4 oxygens. यहाँ पे 3 + 1, that's 4 oxygen as well. ठीक है, तो clear है? Is this clear, this one?
Yes.
Yes, sir.
अच्छा, फिर ये कि एक सेकंड में कॉल अटेंड अच्छा सॉरी, चलो ये वाला कर ले क्वेश्चन के there's a lithium iodine electrochemical cell that can be used to generate electricity for a आवाज आ रही है ना, हाँ, for a heart pacemaker. The cell consists of a lithium electrode and an inert electrode immersed in body fluids. When current flows, lithium is oxidized and iodine is reduced. तो बस उसने कहा बता ही दिया कि क्या हो रहा है, ठीक है. He told us that lithium is getting oxidized and iodine is getting reduced. Use the data booklet to write half equations for the reactions taking place at the two electrodes. Well, why data booklet की क्या जरूरत है? I mean, he already told us that lithium is getting oxidized and iodine is getting reduced. लेकिन खोल लेते हैं data booklet, ठीक है. कहाँ है data booklet? This one. So lithium is getting oxidized. Where is lithium? Li कहाँ पे है? L कहाँ गया? Lmn. हाँ, this is lithium, ठीक है. So this is your lithium. अच्छा, this is your lithium equation. minus 3.04 volts. और कौन था? आयोडीन. आयोडीन इसके साथ ही ऊपर, ठीक है. This is your iodine. अच्छा, this is your iodine equation. That's 0.54 volts. बात वही है कि we already know the higher potential gains electrons, the lower potential loses electrons. So higher gains and the lower, अच्छा, lower loses, ठीक है. और वही हो रहा है. This is the lower potential, this is the higher potential. Iodine gets reduced, lithium gets oxidized, ठीक है. तो वही हुआ है जो मतलब there was no point in opening the data booklet even. तो कहाँ गया क्वेश्चन? कहाँ गया? एक सेकेंड. अच्छा, so this one. Lithium got oxidized. Lithium lost electrons, one electron specifically, lithium +1. And वो दूसरा क्या था? Iodine gained electrons. और इसका simple क्या होगा? It's going to be, I mean, the first equation has to be electrons gain and loss. They have to be they have to be made equal, multiplied by 2. Overall equation is you're going to sum them up. So it's going to be 2Li plus I2. And the product is 2Li plus 1. And 2I minus 1. ठीक है, ये आपका रिजल्ट आ गया. इज आस्किंग फॉर द ई नॉट सेल, तो आई जस्ट ओपन द डेटा बुकलेट अगेन. ठीक है, ओवरऑल ई नॉट सेल क्या होगा? दैट्स गोइंग टू बी हायर पोटेंशियल माइनस लोअर पोटेंशियल. सो इट्स गोइंग टू बी 0.54 और 3.04. उनका डिफरेंस 0.54 minus 3.04. So that's going to come out to be 3.58 volts, which is very high. That means the reaction is going to be very, very fast. तो मतलब उस cells में obviously one side lithium has a very low potential. It likes to lose electrons, so which is why it's a very good. Lithium ion batteries are very good. ठीक है, चलो clear है? पिछला question clear है?
Yes.
अच्छा, अब ये अगला फिर. A current of 2.5 into 10 to the minus 5 ampere is drawn from the cell. Calculate the time taken for 0.1 gram of lithium electrode to be used up. Assume that the current remains constant throughout this period. तो वो क्या था? लिथियम लूज कर रहा था ना इलेक्ट्रॉन. So lithium was turning into what? Lithium +1. +1 electron. तो he's saying के lithium electrode जो है ना कितना? 0.1 gram, right? So 0.1 gram. How many moles is this? 0.1 gram. That's 0.10 grams divided by mr, which is क्या होता है lithium? Lithium. वो बैठ के find it in the pure table. अच्छा, lithium 6.9. अच्छा बताओ, how many moles do you get? इधर कैलकुलेट करो ना, कितने मोल्स है?
So 0.0145.
अच्छा, 0.0145 moles. अच्छा moles आ गए. So the moles of electrons are also going to be exactly the same, 0.0145 moles. और फिर मैंने क्या कहा था कि if you Faraday constant, right? Faraday constant was that 1 mole of electrons will have how much charge? It will have a charge of 96,500 coulombs. To dissolve 0.1 gram, these many moles of electrons need to pass through the circuit. So what is the charge that's flowing through the circuit? Yeah, 0.0145 को multiply करो 96,500 coulombs. So how much charge is this equal to?
So 1,400.
So 1,004. So 1,400 coulombs, right? So Q is equal to IT. Charge is equal to current into time, right? So the current is already known. That's 2.5 times 10 power minus 5 amperes. So all you need to know is time. So find out what time is. 1,400 coulombs, so seconds. In seconds, how many seconds is that?
So 5.6 times 10 power 7 seconds.
That's a 10 power. That's a 10 power 7 seconds, right? ठीक है, so
Yes.
that's it. That's it. ठीक है. So just remember Q is equal to IT, and if you know the moles of electrons, you can find out charge. To next one. ये वो drawing करिए. State the material used for the electrode in each half cell. As a bromine, if the bromine Br-1, that's going to be a platinum electrode. ठीक है. Remember, platinum electrode जो था, it was always there when you didn't have a metal. The other one, again, you don't have a metal, so that's also going to be a platinum electrode. It's only ions. तो उसको रिवाइज भी कर लेते हैं. Remember, they were किस वाले में किया था हमने? ये भी नहीं खोल रहा. अच्छा, just remember there were 3 types of electrodes. ठीक है. Metal ion electrode, जिसके अंदर metal is the electrode, and then you had a ion only electrode, which had ions in the solution, and you had a platinum electrode. And then there was a gaseous electrode, जहाँ पे gases होती थी. उसके अंदर भी you had a platinum electrode. Now the question is, the cell is operated at 298 kelvins. Has standard concentrations. ठीक है, so one of the electrode has standard concentrations. The Mn3 plus Mn2 plus half cell does not have standard concentration. Standard concentration क्या होती है? 1 mole per dmq. So now you got your Nernst equation, which is उसने calculate the electrode potential of this electrode, the other one, which is non-standard. So Nernst equation थी क्या? It's E is equal to what? E naught, the old potential, plus 0.059 divided by Z था, and log of oxidized over reduced. So the first thing is I need to find what the standard potential was. Mn3 plus, Mn2 plus. तो कहाँ गया हमारा वो? अच्छा, Mn3 plus, Mn2 plus. यहाँ पे तो है नहीं. अच्छा, I think it's this one. ये वाला. I think it's 1.49 moles. Mn3 plus, Mn2 plus. That's 1.49 अच्छा, that's 1.49 volts. अच्छा, प्लस के इलेक्ट्रॉन्स कितने हैं? That's one, just one electron, 0.059. Divide by 1. Z was the number of electrons in the equation. This equation where there's only one electron being gained and lost. So then log of oxidized species over reduced species. Oxidized is the one that's on the जो oxidized होने के बाद बना है, ठीक है? That's the Mn3 plus, that's 0.5. Reduced species is the one that's formed after reduction. That's Mn2 plus, so that's 0.1. So basically 5 हो गया ना, log 5 लेना है. So 1.49 plus 0.059 log 5. What do you get?
$1.531.
ठीक है, 1.531 volts. 1.49 था, now it's 1.531 volts. अब फिर वो कह रहा है E naught cell under these conditions. So bromine वाले का we already knew that it was what bromine वाला, that's I think 1.07. But data booklet में it's 1.07 volts. ये जो दूसरा वाला है ना, under non-standard condition, that's 1.531. So क्या होगा? It's going to be reduction, higher gains, lower losses, right? Reduction minus oxidation. So E naught cell would be 1.531 minus the other one, which is 1.07. अगर 1.53 लेते हैं तो I think it's going to be 0.46. अच्छा, it's going to be 0.46 volts. So, and right, the overall equation for the cell reaction. तो वो पहले मैं उधर से लिख लेता हूँ. उधर क्या था? BR and where's BR? अच्छा, BR बिल्कुल टॉप पे है. So इधर मैं कॉपी कर लूँ. He's saying, right, the overall reaction. So one of the electrode was this one, Br2 plus 2 electrons, 2 Br minus 1. अच्छा, कितना? 1.07 volts. The other one is Mn3 plus 1 electron in equilibrium with Mn2 plus. This is 1.49 volts. No, not 1.49, वो change हो गया था इसका. It was actually 1.53 volts. बस क्या करना है? Higher potential gains and the lower potential loses. So forward, backward. This equation has to be, Mn wali has to be multiplied by 2, so it's going to be reactants, 2Br minus 1. Mn wala jo reactant is, that's 2Mn3 plus. Product here, first wale mein it's Br2. And what's the product in the second one? That's 2Mn2 plus. ठीक है, so remember कि जो नीचे वाली equation है, that's been multiplied by, so that's been multiplied by 2. So that's it. अच्छा, अगला वाला, ये पिछला क्लियर है ना? ये क्लियर है पिछला?
Yes, sir.
अच्छा, अब ये next question, part C, right? Achha, that's surprisingly, it's a 5-mark question. It's a big question, but it's a Faraday constant question. The only problem with this question, I mean, pretty much everyone got this wrong. Okay. Question के assumption में बता देता हूँ कि the assumption of the question is that you have to find not the assumption, the question is that you have to find the Avogadro's constant. जब ये question आया था ना, problem ये आई थी कि when he's asking you to find the Avogadro's constant, then you can't use anything that uses the Avogadro's constant. I mean, you can't use that. For example, like if you don't even know what the Avogadro's constant is, so you will not know what the Faraday constant is. वो भी नहीं पता होगा ना, क्योंकि you can't really calculate. Faraday constant क्या होता था? Faraday constant was the charge on 1 mole of electrons, right? 1 mole of electrons was 6.02 times 10 power 23, right? That many electrons. And each electron had a charge of 1.6 times 10 power minus 19 coulombs. तो तब पता लगता था कि वो 96,500 coulombs, right? But now we've got a problem. You can't use the Faraday constant. Why? Because you don't know what the Avogadro's constant is. If you don't know what the Avogadro's constant is, then how would you calculate the Faraday constant? You wouldn't be able to calculate the Faraday constant. ठीक है? तो इस फॉर्मूले से ना, ये जो F is equal to LE मैंने लिखवाया था ना, this was the formula. Avogadro's constant L multiplied by the charge on one electron. This was the formula. So I mean, that formula is pretty much useless. You can't use that formula. ठीक है? As the problem with this question was that most students, they kept on using 96,500 coulombs in this question, which is why it came out to be wrong, because पता ही नहीं है कि वो 96,500 coulombs है, because you don't know what the Avogadro's constant is. तो ये assumption लेके ना, you have to start the question that you don't know what the Faraday constant is, because you don't know what the Avogadro's constant is. ठीक है? So basically you have to find the Faraday constant and you have to find the Avogadro's constant as well. They're both interdependent. So इसलिए 96,500 coulombs cannot be used because you don't know if it's 96,500 coulombs. Now the question is कि वो copper is being electrolyzed, so copper is deposited. वो उसकी वही equation होगी कि copper ions will go to the cathode. They'll probably gain 2 electrons and they'll become copper, right? So he says that 5.09 grams of copper is deposited at the cathode. 5.09 grams. मुझे लिखा हुआ 5.09 grams. So how many moles is this? Copper, I think, क्या होता है? 63.5, I guess. AR, that's देख लेते हैं 63.5, ठीक है. So इसके moles निकालो. How many moles is this?
So 0.0802.
That's a 0.0802, right?
Yes, sir.
So electrons के moles क्या होंगे? That's going to be double, right? So double that, so it's going to be 0.1604. यही होंगे ना?
So just 0.160.
4 किधर गया? So
No,
ठीक है.
4, sir. It's 3. It's 3. It's 3.
So forget it. It was 160, right? So you find the moles of electrons, right? And you can calculate the charge that's flowing through the circuit because current and time both are given. So charge कितना flow कर रहा है? Charge is what? Charge is 1.5 amperes current into time. Q is equal to IT. So time कितना? That's 3 into 1 hour is 3,600 seconds. तो क्या आ रहा है?
So 16,200.
So getting 16,000. You're getting 16,200 coulombs, eh? So that means, what does that mean? Okay, it's these many electrons, 0.16 moles electrons, right? So the charge that's flowing through the circuit is 16,200 coulombs. So I can now calculate the experimental Faraday constant. Because I know the ratio. Okay, but remember, it's going to be this is going to be the experimental Faraday constant. Okay, we point kitna 160 moles of electrons. That's equal to how much charge? That's equal to 16,000. 200 coulombs, right? तो 1 mole electron पे कितना charge होगा? So you have to find that. तो लेकिन remember ये वो formula से नहीं आया. This is the experimental Faraday constant. So what do you get? What do you get as the experimental Faraday constant?
So 101250.
So you're getting 101250 coulombs, right? So your
Yes.
experimental Faraday constant is 101,250 coulombs, right? तो अब formula apply कर दो क्योंकि you know the experimental Faraday constant. You don't know what the Avogadro's constant is. You know the charge on 1 mole of electrons that's also given over here. That's 1.6 times 10 power minus 19. So Nikala, what is the Avogadro's constant now?
So 6.33 times 10 power 23.
Times 10 power?
23.
Approximately close enough, right? Achha, so a lot of people were not able to do this question because they kept thinking थोड़ा सा unfair question भी था because they kept thinking that Faraday constant is 96,500 coulombs. मतलब यहाँ पे उनको कह देना चाहिए था कि but you can't use this. ठीक है? You would have to find the Faraday constant experimentally and then use that to figure out what the Avogadro's constant is. लेकिन clear है question clear है सारों को? साथ clear है? Varun, Ahmed, Tasneem, is this clear?
Yes.
Yes, sir.
The next one, explain why magnesium metal cannot be obtained by the electrolysis of dilute aqueous magnesium sulfate. Your answer should include बस ये last कर लेते हैं कि क्या मसला है magnesium sulfate, right? Cathode anode पूरा electrolysis कर लेते हैं. अच्छा, aqueous magnesium sulfate, cathode will be magnesium ions and anode will be sulfate ions. Positive anode, negative ions, right? And water is going to be present on both sides. Remember मैंने कहा था कि water does not get ionized a lot, so there's not a lot of H+1 or OH ions. वो अगर यूज भी करोगे ना गलत नहीं होगा, ठीक है? But लेकिन यहाँ पे he's asking for the data booklet explanation as well. So okay, why is magnesium not obtained? The electrons are coming in, so it's going to gain electrons. So it's either going to be magnesium. Cathode पे remember only reduction happens, only gain of electrons. So either it's going to be magnesium or it's going to be water, right? तो जाके देख लेते हैं. Remember gain of electrons. Only option is, so I'm looking for equations in the forward direction where the substances are gaining electrons. तो क्या था kind of data booklet. I said magnesium or water. So I've got magnesium gaining electrons, right? Forward, say forward में देखना है, gaining electrons. That's minus 2.38. And the other one is water, that's gaining electrons. That's what? That's minus 0.83. So electron gain कौन करता है? That's the higher potential. So the higher potential is the one that's going to gain electron, and hydrogen gas is going to get produced. Magnesium has a very low potential. Low potential does not like to gain electrons. तो वो तो हो नहीं सकता. So answer में all you have to do is you're going to code the two equations and you're going to tell them that Water has a higher reduction potential or has a higher tendency or a higher potential, higher electrode potential. Hence, it is the one that's going to gain electrons. ठीक है, बस ये. Is this clear? This one?
Yes, sir.
बाकी चले वो ज्यादा इसी तरह एक होमवर्क रख लो कि try doing मतलब इसके पेज first 20 pages, right? ये वही worksheet, I've sent the worksheet. तो मैं उधर लिख भी रहा हूँ. अच्छा, इंटरनेट प्रॉब्ली होगा भी नहीं यहाँ पे शायद for 2 days. ठीक है. अच्छा, लाजमी अटेम्प्ट करना था कि थोड़ा सा, क्योंकि अभी जब आप प्रैक्टिस करोगे ना, एटलीस्ट थोड़ा सा, ऑल्दो देयर इज नो एग्जाम नियर बाय, ठीक है, लेकिन थोड़ा बहुत वो आप प्रैक्टिस करोगे तो मेमोरी वगैरह रिटेन रह जाएगी. ठीक है, चले. ओके एवरीवन,
Thank
ठीक
you,
है.
sir. Allah Hafiz.
अल्लाह हाफिज.